All right, this video on probability and set theory. There's a lot of vocab, so you'll need to pause the video as we go here. Some of this notation you should be familiar with. We've talked about empty set, so you should know this notation. Other notation you may be less familiar with. All right, so we've got two tables where we're going to explain a lot of the vocabulary from this section. So in this first column, we have basically come up with 4 different sets. Starting with set A. Set A is the set of prime numbers less than 10. So the notation for that is capital A, and we're going to write all of the elements of set A in curly braces. So the elements are the numbers less than 10 that are prime numbers. So that is 2, 3, 5, and 7. Remember, a prime number is something divisible by 1 and itself. And then the last column says the number of elements in the set. So we're going to write lowercase n for number, in parentheses capital A, because it's set A. So the number of elements in set A in this example is 4. 2, 3, 5, 7. It's 4 numbers. So we'll do the same thing for sets B and C. Set B is the set of even natural numbers less than 10. So that's 2, 4, 6, 8. Natural numbers are counting numbers. That excludes all the decimals in between. And then same thing, the number of elements in set B, there are 4. Set C is our smallest set. It's the set of natural numbers less than 10 that are multiples of 4. So 4 is a natural number less than 10 that's a multiple of 4, and so is 8, and that's it. So we're going to use these sets on the next example here in just a second. And then finally, you've got the universal set. If you know the term sample space and probability, they're interchangeable. But here we're going to use the term universal set. And we've obviously got a capital U there to denote universal set. For the number of elements in set U, there's 9. And of course, sets A, B, and C are all nested inside of set U there. So the next page, you'll see first off I have rewritten sets A, B, and C, because we're going to use those in this second table. So in the second table, we're going to introduce a few more vocab words. The first one is the vocab word of subset. So set C is a subset of set B if every element of C is also an element of B. So let's check that out. The elements that are in C are 4 and 8. Are both of those elements also in set B? Yeah. So that means set C is a subset, and there's the notation of set B. Set C is nested on the inside of set B. The Venn diagram for this problem, what it would look like, we're going to start by drawing a circle for set C. And it's going to be nested on the inside of set B, since C is a subset of B. And of course, they're both subsets. We're going to use a box or a rectangle or a quadrilateral. They're both nested inside the universal set. For this specific example, for set C is 4 and 8. It's nested inside of set B. And the elements of B were 2, 4, 6, and 8. But we're not going to write 4 and 8 again because we've already written them. So just 2 and 6. And then finally the universal set. Everything else that's in the universal set has not already been included. And it's basically the odd numbers at this point. So it's 1, 3, 5, and 7. So notice all the numbers from the universal set are included either in red or on the inside of those circles. All right, the next key vocab word is intersection. The intersection of set A and B is the set of all elements that are in both A and B. So intersection and the conjunction word and go together here. The notation. So A intersects B, So it's kind of upside down U there. There's the notation. It's not really the letter U, but just that general shape. So here, when we draw this Venn diagram, we want to know where these two sets intersect, where they overlap. So when I draw set A as a circle, I'm going to make sure it's a separate circle from set B, but they do need to overlap. And of course, all of this is a subset of the universal set. But in intersection problems, our solution, again, is where they overlap. All the numbers that are in both of those sets. So for this particular example, we want to find out where A and B intersect. Well, they only have one number in common, and it is the number 2. So 2 should go in that double shaded region. But in set A also includes numbers 3, 5, and 7. And set B also includes the number 4, 6, and 8. And then let's draw our universal set. What's left? 1 is left. And 9 is left. That's it. So intersection and the word and go together, and union goes with the conjunction word or. So union of sets A and B is the set of all elements that are in A or B. So union symbol, again, looks like a U. It's not a U. It's that same general shape. For a union problem, I'm going to go and draw the universal set. We're still talking about sets A and B. So I'm going to draw it the same way I drew the last example, but here our solution for A union B is everything that is in set A or set B. So basically, we're talking about all of the elements combined when it's a union problem. In this specific example, again, it's going to look identical to the one we did earlier. 3, 5, and 7 are in set A. We overlap 2. And then the universal set, 1 and 9. So our answer for what numbers are in A or B, well, it's everything. That's 3, 5, 7, 2, 4, 6, 8. So if they ask for the union, you would write every single number. You'd be careful not to write 2 twice. I'm not going to shade everything because obviously, again, we be covering the numbers up. But it's everything that's in both of those sets when we're talking about a union problem. And then finally, the notation for complement. It's the last vocab word. The complement of set A is considered the set of all elements in the universal set that are not in A. Really, it means, complement means not in set A. So when we draw this, we got the universal set. We're only talking about one other set, and it's set A. The complement of set A is everything that's not in A. So our shaded region would be everything in the universal set that's not in set A. So this specific example, set A is 2, 3, 5, 7. So the complement of A is 1, 4, 6, 8, and 9. So our solution are those numbers right there on the outside of the circle. So 1, 4, 6, 8, 9. Those are considered the complement of set A. Then we'll finish with some practice problems. So this one says set A is the factors of 12. And it's left off, but it should be the factors of 12 less than 13. I think it's included everywhere else. But set A is the factors of 12 that's less than 13. So I'm going to go and write out the elements. Factors of 12 that are less than 13. 2 is a factor of 12. 4 is. 6 is. And 12 is. Oh, and of course, 1 is as well. 1, 2, 4, 6, 12. Those are all factors of 12. Set B. All of the even natural numbers less than 13. So it's 2, 4, 6, 8, 10, and 12. Set C. All the odd natural numbers less than 13. So there's set C. Set D is the set of even natural numbers less than 7. So that's just 3 numbers. And of course, the universal set is all 13 natural numbers. So the first question asks, is D, so think about what that symbol means, is D a subset of set A? Is every element in D also in? Well, the elements of D are 2, 4, and 6. 2, 4, and 6 are all in A. So yes, set D is 2, 4, and 6, and all of those elements are nested inside set A. These other questions, so the bolded question is actually the question underneath is really what it's asking. So the next one is every element of B also an element of A. So look at set B. Set B is 2, 4, 6, 8, 10, 12. Are all of those numbers also in set A? No. Number 8, for instance, is in set B, but it's not in set A. Number 3 wants to know what is A intersection B, or in other words, what numbers are in A and B. So this is just where those two sets overlap. So they both have a 2, they both have a 4, they both have a 6, and they both have a 12. Number 4 wants to know where do sets A and C intersect at. So what numbers do A and C both have in common? They both have a 1, and that looks like it's it. Almost an empty set. Number 5, what is A union B, or in other words, what numbers are in A or B? So this is going to be a longer list. So we want every number that's in A or B without repeating ourselves. So in set A, we've got 1, 2, I'm going to try to write these in numerical order, 4, 6, and 12. I'll write 12 at the end. And then in set B, what numbers did we not mention already? We didn't mention 8 and 10. So those are all the numbers in sets A or set B without repeating ourselves. Number 7 wants to know what is the complement of A. So basically what's not in A that's in the universal set. So the universal set, remember, goes from 1 to 12. It's the numbers less than 13. So 3 is not in set A. 5 is not in set A. 7, 8, 9, 10, and 11. Go and try problems number 6 and 8. All right, and there is the last 2 answers.